In this introduction, I'm going to briefly explain what is flash column. So flash column is a machine or in chemical engineering term, it's called as a process unit. So this process unit function as a separation method to separate one desired product from its mixture. To know how the flash column operates, Amiron will later explain it in this video. So our background of our project is that we have been given a task from our lecturer in chemical engineering thermodynamic class, where we have to design a flash column which we have to separate benzene and hexane. So thus we have created certain objective to be achieved from this project. So one of them is to construct the process conditions such as the overall composition and the operating temperature and pressure. And on the other hand also, the other objective that we also aimed is to determine the numbers of mole of liquid and vapor and their respective phase mole fraction of both n-Hexane and benzene.
So I will explain how the flash drum is work or operation of flash drum. So I will divide into four process. The first step, the mixture is need to preheat. The mixture maybe can be heat by through a heat exchanger, direct heater or electric heater. The reason why the mixture is need to preheat is to make sure the mixture is at specific or requirement temperature before enter the flash drum. For second step is fat entry. Mixture enter the flash drum by using a pump. As you can see in the picture, the circle one, the reason pump is used is to maintain the flow rate and ensuring the mixture is delivered at appropriate pressure. Usually the inlet of the flash drum is located on the top of the flash drum or at the side of the flash drum. The function of the valve, as you can see in the picture, before the mixture enter the flash drum, the function of that valve is to prevent the backflow. Next, we go to step 3, which is pressure drop and flashing. Pressure drop is occur when the mixture exposed to low pressure environment or sudden contraction condition. So the pressure will drop from higher pressure to low pressure. Flashing. Flashing is the condition from liquid phase to vapor phase instantly. This is occur due to liquid temperature is higher than its boiling point. So last step is phase separation. So after we go step by step until the mixture enter the flash drum and flashing occur until the some mixture turn into vapor phase instantly, we go to separation part. Usually flash drum has two outlets, which is top and bottom outlet. So basically separation occur due to different density. The vapor phase being less than, so rise to the top, and liquid phase being denser, so settle at bottom outlet. So each phase are stored in different storage tank through different outlet. So this is the application of the flash drum. For example, is oil refining. Same like for step before. First, the crude oil is is heated, then introduced into the flash drum, and pressure drop and flashing occur. Then lastly, separation part, which is separate the diesel from the gasoline.
Species and process condition. A mixture of n-Hexane and benzene is used in the flash to separate the mixture. Few assumptions are made in this project. First is the mixture is ideal solution. Second is the mixture is equimolar. The system is operated at the temperature 70 degrees Celsius and also the pressure is 88 kilopascal. By referring to the table A1, we have found the constants A, B, C values for both substances, benzene and n-Hexane. We have used the equations given there and to find the vapor pressure in two different units such as kilopascal and mmHg.
Just now we have calculated the saturated pressure for both substances. Right now we will calculate the bubble point pressure and the dew point pressure of this system. First, we will assume the Z1 and Z2 are equal to zero point 0.5. So we will calculate the bubble point pressure with the given formula, and the value that we get is approximate to 89 kilopascal. Secondly, we will calculate the dew point pressure with the given formula too, and the value that we get is approximate to 86 kilopascal. So the operating pressure that we selected is equal to 88 kilopascal in order to let the system exist in two-phase system. After this, we will use the K value correlations, and with equal to the Root's law, we can get the both K values, and these K values will be used in the later calculation. Alright, now so we will need to find the value of the V, which is the mole of the vapor. So we will calculate the value of the V with the formula given. So from the previous calculation, we have determined that the Z1, the Z2, K1 and K2. So we substitute all of these values into the equation and we take V is equal to 1. So we will solve the equation quadratically and we will get two answers, which is V1 equal to 1 and V2 equal to 0.568. And the value of the V1 we rejected, and we will get the value of the V is 0.568. Just now we have calculated the value of the V, and right now we can calculate the value of the L, which is the mole of liquid, by simply 1 minus V, and we get the value of L is 0.432 mole. After this, we can calculate the moles fraction of vapor with the given formula, and we can get the two values of Y1 and Y2. After that, we can calculate the moles fraction of liquid 2 with the answer that we have calculated from the moles fraction of vapor, and we can get the both values of x1 and x2.
We could obtain the TXY diagram from the composition we calculated. So this is the diagram for benzene at temperature 70 degrees Celsius. Next, this is the PXY diagram for n-Hexane. We could see the values of Y2 and X2 at pressure 88 kilopascal.
From the overall assumption and the calculation that we have made, finally we can draw the process flow diagram or PFD. So here is the PFD of the flash column.
There are some safety precautions that we need to follow when handling these chemicals. The first one is wear protective gloves and proper clothing. The second is keep these chemicals in a tight container and store it in a well ventilated place after using it. The third one is keep the chemicals away from any heat because they are highly flammable. And the last one is wash your hands immediately because it could cause skin irritation. In conclusion, the operation of flash drum consists of feed preheating, feed entry, pressure drop and flashing, and phase separation. For the calculation, firstly we use n-Twain equation to get the values of saturated vapor pressure for benzene and n-Hexane. Then we use the bubble point and dew point equation to obtain the operating pressure by assuming Z1 and Z2 is zero point 0.5 mole, which we get 88 kilopascal for the operating pressure. Then we use the Rolle's law to get the values of K1 and K2. After that, we did the iteration of V to obtain the moles of vapor and moles of liquid. Lastly, we calculate the compositions of vapor and liquid using their respective equation. So in summary, after getting all the values of V, L, Y1, Y2, X1 and X2, we could draw the complete process flow diagram.